Welcome to Lesson 1.2. In this lesson we'll be reviewing some of the basic skills involving fractions. We'll first review how to convert a mixed number to an improper fraction. A mixed number is a whole number and a proper fraction. An improper fraction is a single fraction where the numerator is greater than or equal to the denominator. So we first want to convert 3 2/7 to an improper fraction. Following the procedure outlined above, we first multiply the denominator in the whole number, which would be 7 times 3. Step 2, we add the numerator, which in this case would be plus 2. We write the result over the original denominator, which in this case is 7. And now we'll simplify using the order of operations. So we multiply first. 7 times 3 is equal to 21. So we have 21 plus 2 all over 7, which gives us 23/7 as our improper fraction. Let's look at the model below for 3 2/7 to understand why this procedure works. Notice these 3 bars represent the 3, where each bar is partitioned into 7 equal pieces. So 3 is equal to 7 plus 7 plus 7, or 21/7. And then we have plus these 2/7, which gives us 23/7. Notice how the 7 times 3 gives us a number of 7ths in 3, and the plus 2 here gives us the remaining 2/7, giving us a total of 23/7 for the improper fraction for 3 2/7. For 12 1/3, again as an improper fraction, we'd have the denominator times the whole number, so 3 times 12 plus the numerator of 1 all over the original denominator of 3. 3 times 12 equals 36, so we have 36 plus 1 all over 3. So 12 1/3 equals 37/3. Now let's review how to write an improper fraction as a mixed number. We first want to write 42/5 as a mixed number. So step 1, we divide the numerator by the denominator. So we'd have 42 divided by 5. And there are 8 5s in 42. 8 times 5 equals 40. We subtract. And notice how here we have a remainder of 2. The quotient becomes the whole number part of the mixed number, and the fraction part is the remainder over the denominator. So 42/5 is equal to 8, and the fraction is going to be the remainder 2 over the divisor, or the original denominator, which would give us 2/5. Now let's look at the model below to see why this works. Here we have a total of 42/5, where every time we have 5/5, we have one whole. So notice how 42/5 is equal to 1, 2, 3, 4, 5, 6, 7, 8, and 2/5. Next we have 53/9. So we'll take 53 and divide by 9. And there are 5 9s in 53. 5 times 9 equals 45. And we subtract, and we have a remainder of 8. Which means 53/9 is equal to 5, and the remainder of 8 over the denominator or divisor of 9. Now let's talk about equivalent fractions. Equivalent fractions are different fractions equal to the same amount or same value. Here we have 3 models of 3 equivalent fractions. Where if this rectangle is one whole, notice how for this model we've cut or partitioned one whole into 4 equal pieces, one of which is shaded, so this model's the fraction 1/4. For the next model, notice how we have one whole cut or partitioned into 8 equal pieces, 2 of which are shaded, so this is the model for 2/8. Notice here we have 2 different fractions, but they're equal to the same amount or the same value, because notice how the same amount is shaded. So 1/4 and 2/8 are equivalent fractions. Here one whole is cut or partitioned into 12 equal pieces, 3 of which are shaded, so this model is 3/12. Notice how these 3 fractions are equivalent fractions. So if we're given a fraction, for example 1/4, to come up with another equivalent fraction, we can simply multiply the numerator and denominator by the same value other than 0 and 1. So for example, if we multiply the numerator and denominator by 2, we'd have 1 times 2 over 4 times 2. Notice how this gives us 2/8, which we can see from our model is an equivalent fraction to 1/4. If we multiplied 1/4 by 3 over 3, or multiplied both the numerator and denominator by 3, notice how we'd have 3/12, our second equivalent fraction to 1/4. By multiplying by 2 over 2 or 3 over 3, we're simply multiplying by 1 but changing the form of the fraction. So for example 3, we're asked to find two equivalent fractions to 2/7. So there's an infinite number of equivalent fractions we can find. For our first equivalent fraction, let's multiply the numerator and denominator by 5. So we'd have 2 times 5 over 7 times 5, which is equal to 10/35. 10/35 is equivalent to 2/7. For our second equivalent fraction, let's multiply by 11. So we have 2/7 would be equal to 2 times 11 over 7 times 11, which is equal to 22/77. These would be two equivalent fractions to 2/7. Of course, there's many others that we could find. Next, we want to simplify the following fractions. A fraction is considered simplified if the only common factor between the numerator and denominator is 1. So for 3/18, notice how both 3 and 18 share a common factor of 3, and therefore 3/18 simplifies. So just like before when we were multiplying the numerator and denominator by the same value, we can simplify a fraction by dividing both the numerator and denominator by the same value. So here, we can divide out the common factor by dividing the numerator by 3 and dividing the denominator by 3. Notice how now we'd have 1 over 6, or 1/6, which is a simplified form of 3/18, because 1 and 6 only share a common factor of 1. Next we have 42/54. Notice how 42 and 54 do share a common factor of 2, but they also share a common factor of 3, and therefore the greatest common factor of 42 and 54 is 6. So to simplify this fraction in one step, we would divide both the numerator and denominator by 6. "42 divided by 6 is equal to 7, and 54 divided by 6 is equal to 9. The only common factor between 7 and 9 is 1, and therefore we know 7/9 is a simplified form of 42/5. But I do want to take a look at this again. Sometimes we may not recognize the greatest common factor, and it may take more than one step to simplify a fraction. So for example, if we start again with 42/54, and let's say we first recognize there's a common factor of 2, so we'd have 42 divided by 2 over 54 divided by 2. This would give us 21 over 27, but this fraction still simplifies because 21 and 27 share a common factor of 3. So now we would divide the numerator and denominator by 3, which would give us the final simplified fraction of 7/9. So there's nothing wrong with taking more than one step to simplify a fraction. We can only simplify it in one step if we recognize the greatest common factor between the numerator and denominator. I also want to mention there's also another common way to simplify a fraction by writing out the prime factorization of both the numerator and denominator. For example, again looking at 42/54 again, the prime factorization of 42 would be 2 times 3 times 7, and the prime factorization of 54 would be 2 times 3 times 3 times 3. The nice thing about doing it this way is that we can actually see the common factors. 2 divided by 2 simplifies to 1. 3 divided by 3 simplifies to 1, giving us our final simplified fraction of 7/9. So there is more than one way to simplify fractions. And now for the last example, we're asked to simplify the following fractions if possible. Before we take a look at these though, remember a fraction bar means division. So for example, if we have 15/3, that means 15 divided by 3, which is equal to 5. And every division problem has a corresponding multiplication problem. 15 divided by 3 equals 5 because 5 times 3 equals 15. Notice how the corresponding multiplication problem is formed by looking at the division problem in the opposite direction. 5 times 3 equals 15. So our first fraction is 1/4, and we know from above this does not simplify because the only common factor between 1 and 4 is 1, so let's just write 1/4 equals 1/4. If we did want to model this fraction, we'd have 1 whole, cut or partitioned into 4 equal pieces, one of which would be shaded. Next we have 4/1, which means 4 divided by 1, which we know equals 4. The model for this, because the denominator is 1, we'd have 1 whole, cut or partitioned into 1 piece, which we already have, and we'd have 4 of these, giving us a total of 4. And also notice the corresponding multiplication problem would be 4 times 1 equals 4. Next we have 4/4, which means 4 divided by 4, which equals 1. Notice how the corresponding multiplication problem would be 1 times 4 equals 4, which we know is true. The model for this would be we'd have 1 whole, cut our partition into 4 equal pieces, and because the numerator is 4, we have 4/4, which equals 1 whole. Next we have 0/4, which means 0 divided by 4, which is equal to 0. The reason we know this quotient equals 0 is because the corresponding multiplication problem formed in this direction would be 0 times 4 equals 0, which we know is true. The model for this would be we'd have 1 whole, because the denominator is 4, we'd cut our partition this into 4 equal pieces, but because the numerator is 0, we have 0 of these pieces, which would be equal to 0. And finally we have 4/0, which means 4 divided by 0, and division by 0 is always undefined. To justify why it's undefined, notice how the corresponding multiplication problem formed in this direction would be some number times 0 must equal 4. And we know there's no number times 0 which equals 4, verifying this quotient or division by 0 is undefined. Using a model for a fraction, there's no way we can take 1 whole and cut or divide it into 0 equal pieces. It's just not possible, again verifying our quotient is undefined. Okay, I hope you found this helpful.